Hypothalamus artificial intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presence. Optimization of locomotive scheduling. It involves the design and implementation of an optimization model for the assignment of locomotives to trains in circulation, considering the key characteristics of locomotives. The model must allow adjustments to be made to the allocation of locomotives for regular trains and to generate new assignments in case of failed locomotives or additional trains. Challenge: automate the assignment of locomotives to already scheduled travel trains. Solution: design and implementation of an optimization model for the assignment of locomotives to trains in circulation, considering key characteristics of the operation of the system. It executes the assignment process periodically, scheduled, or manually, run the process at the request of the user, and by events due to an eventual abnormal situation. HI develop and use the mathematical model in a proof of concept, POC, for Ferromex that operates more than 8,500 kilometers of railways and connects 5 cities along the border with the United States, 4 ports on the Pacific coast, and another port on the Gulf of Mexico. The POC was coordinated under a business partner agreement with IBM. Ferrocarril Mexicano, Ferromex, is a private railway consortium that operates the largest railway network in kilometers in Mexico. Ferromex is a Class 1 railroad according to the Association of American Railroads, AR. It began operating on February 19 in 1998, following the privatization plan of Ferrocarriles Nacionales de Mexico. It is a company that has its main activity in cargo transport, and only offers 2 tourist routes, Chepe and Tequila Express. This requires developing the offer of services in freight and passenger transport, which are different, since freight trains are dispatched on demand, while passenger trains are dispatched according to a timetable. The main products transported are agricultural products, automotive, cement, energy, petroleum products, and metals and minerals. The type of operations are: intermodal, offers intermodal transport of goods in containers and semi-trailers, with different scopes, and industrial products, includes the largest number of customers and products that use the company's services, which can be grouped into the subsegments: food, beverages, sugar, paper, cardboard, forest, electro-domestic, etc. The mathematical model implemented by HI was used, during the POC, to optimize the route Mazatlan, Tepic, Manzanillo, Guadalajara and Irapuato. The modeling was carried out by dividing the route into 4 sections, linking the main cities, or train stations. Several trains flow in each section. A train is defined as a set of locomotives and wagons. Each train has its arrival and departure times to the train stations. Each train is assigned the cargo it must carry. Each section is divided into stretches. Each stretch, or link, is associated with an average slope, which implies differences in energy consumption. At any of the points, nodes, that limit the stretch, locomotives can be incorporated or disincorporated. Locomotives can travel on the train, turned off, only to transport them to a node, where they must come into operation, and in operation, pushing the train. The fuel consumption of the locomotive must be considered, according to its energy productivity, which depends on the slope and load. The mathematical model must determine the nodes in which the locomotives are connected, or disconnected. All physical laws of the rail system must be satisfied, such as maximum load, maximum speed, energy consumption, train displacement, displacement of locomotives, availability of locomotives, and material balance. The main results of the mathematical model are: locomotive assignment scheduling corresponding to each locomotive, according to the train to which it is assigned. Summary of maneuvers, indicates the periods when locomotives are loaded, or unloaded, to trains on the route. Availability of locomotives by period indicates the location of locomotives when they are not assigned. Gantt visually presents the location of the locomotives. The screenshot shows an log-on control window. The train itinerary is divided into sequences. In each sequence, a tonnage of cargo to be transferred is considered. The basic constraint is compliance with the towing capacity required by the train, built as a function of the tonnage to be transported, vehicles and cargo. The model can be considered drag efficiency factors, by sequence or sequence section, depending on the gradient of the terrain. A calendar is managed so that the selection of the date is made by the user. The data window is editable by the user. WHO can change any parameter that appears there. For example, add locomotives, change your features, and modify your operating costs. The table presents the summary of the assignments to the trains, indicating the stretch, and the status, on or off. Indicates the location of locomotives when they are not assigned. Indicates the location of locomotives when they are not assigned. The graph presents the availability of locomotives stopped at stations. The Gantt presents the connection of locomotives to a train. In this case, 8 trains are presented. The Gantt presents the connection of locomotives to a train. In this case 3 locomotives and 1 train, the or my Ms, are presented. Optimization is everywhere.